Good morning, everyone. In this lecture, actually, what I'm going to do is to solve. I'm going to solve certain kinds of problems, and we want to draw the rootlocus plot for the systems given. So, for example, I am taking one open loop system transfer function as an example one, that is GSHS, because you see from the last series of lectures which I have been actually given, or in the last lectures I have given, you see the concept of rootlocus has been discussed, right? So, concept of rootlocus has been discussed means what are the rootlocus plots and why this is so much important, and uh, basic concepts of rootlocus has been discussed. Now here I will try to actually plot the rootlocus corresponding to any system given to you. So different kinds of system I will take and I will solve step by step. Once you go through all the steps and you practice this, so definitely you will be comfortable to solve any kind of problem related to rootlocus plot. And once the concept of plotting rootlocus is clear to you, then definitely certain kind of small questions which are means short answer type questions which are coming in the different examinations, you can be also able to solve, right? So first of all, any system transfer function is given like GSHS, or any block diagram may be given. So from that you have to first identify what is open loop transfer functions. If open loop transfer function is given, that is fine, because rootlocus plot starts from open loop pole positions. First of all, I will actually write side by side some of the basic rules here, and I will try to solve the problem here, right? So first step, I will take open loop transfer functions, that is GSHS equal to K by S into S plus 1 into S plus 3, right? So what is the first step? First step, you have to get the number of open loop poles and open loop zeros, right? So first of all, you have to get the number of open loop poles and number of open loop zeros, and number of open loop poles are denoted by small n, and number of zeros, open loop zeros, are denoted by small m, right? So from this we will solve the denominator to get the pole and numerator to get the zero. So here you will get n. N is the number of open loop pole. So what are the number of open loop pole? 1, 2 and 3. Say these are the number of pole, open loop pole, and within bracket we will write the positions of that pole in. And you see, if you solve this, that means s into s plus 1 into s plus 2 equal to 0. What will get? S is equal to 0, s is equal to minus 1, s is equal to minus 2. That means these three poles are our real poles, right? Or real poles. That means these three poles will be lying on the real axis, because this is your S plane, this is your real axis, this is your imaginary axis. So all the pole positions are to be marked here, and pole positions are marked by cross, right? So we will write here. First of all, the calculations part I will show here, and next how to draw the plot. See, s is equal to 0, s is equal to minus 1, and s is equal to minus 3. So this is minus 3. So these are the open loop pole positions, and you see there is no function of s in the numerator. So open loop 0 m is equal to 0. Once this is 0, so no need to calculate the positions of the open loop zeros, fine. So this is step 1. Next step, I will just explain the rules one by one. What we have to do, next step, we have to just plot these open loop poles and zeros on your millimeter graph paper. Okay, so next I will write here the next step. What is the next step? Plot the poles and zeros on millimeter graph paper, right? And once you take the millimeter graph paper, one thing you have to keep in mind that the axis, that means scale, so this is your real axis, this is your imaginary axis, and when you will take 1 millimeter graph paper, what will do, this is your origin 0 0, and you just scale like this, say this distance is -1. So similarly, this is uniform distance, this is -2, and here we'll get -3, and in the right hand side this is +1, +2, and so on. Now whatever be the scaling, that means this same distance you will take here as your plus j1, because in the imaginary axis you will be having plus j1, similarly this is plus j2, and here you will have to take minus j1 and minus j2, minus j3, and so on. So this is minus j1, minus j2, and so on. What I am trying to say is that the divisions, that means 0 to -1, the same length will have to be taken in this y-axis also. That is the scaling, what is known as scaling. Scaling in both axes same. So 0 to j1 is the distance equivalent to or equal to 0 to -1 or 0 to +1, right? 1 to 2, -1 to -2, j1 to j2, -1 to -j2. So once you get the millimeter graph paper, first scale the graph paper in such a way such that there is divisions in the x-axis and y-axis of the scaling, that means the same length exist for the same values, right? So this is the second plot. Second point is that plot the poles and zeros on the millimeter graph paper. So I am here, say for example, taking like a graph paper. So this is your real axis, this is your imaginary axis, this is negative imaginary, this is negative real axis. So this may starts from -infinity to +infinity, this may starts from -infinity +infinity. This is the range of the values. Now we are taking, this is your 0, and this is 1 2. So in the left hand side you will see this is your -1, -2, -3, and you may see up to -infinity. That means this is your -4, -infinity. These are the points. So similar to that, we will have this is plus j1, plus j2, and in this minus j1 and minus j2. The rule is that you have to take all these values equal on the millimeter graph paper. So I have taken like this. So once this is your millimeter graph paper, what I have to do, I have to plot the poles and zeros. So here we are having only 3 open poles, and what the positions of the poles, you see the positions of the poles are at s is equal to 0, means here there is a pole as s is equal to 0. So this is denoted by cross. So I will mark here like this. Another pole is 8 is equal to -1, that means this is your real value, and another pole is at s is equal to -3. So this is at s is equal to -3, right? So once you put these 3 values, your pole part is complete, and there is no 0. So 0 is not to be put here. 0 is normally denoted by circle, and poles are denoted by cross. This is the denotation of the pole. This is 0. So whenever any 0 will be there, that will be just placed replaced with some circle, right? So this is the positions are the poles are placed, right? So this is number 2. Next you have to find is that which part on the real axis actually lies, that means which part of the root locus is lying on the real axis or not. The third step So what is the third step? Third step is to identify the part on the real axis. See the line, the part on the real axis. Part on the real axis means you have to identify the section on the real axis which will be part of the root locus branch, right? So what is the concept of root locus branch? Basically, when you plot these open loop poles and zeros, next is to find out the real axis section where a root locus branch may exist. Okay, so this is the step, and one step is another step I would like to consider here, that is the I'm going to discuss this. Next is that the root locus branch starts from open loop poles, and terminates at either open loop zeros or at infinity. So that part I will discuss in the next step. So first, our aim is to find out the part of the real axis which A is the part of the root locus branch. So how to find out it? So in order to find out that part, what you have to do, I'm just taking this graph and see here what you have to find out. You have to find out number of open loop poles plus, in order to get this value, what you have to get, the number of open loop poles plus open loop zeros on the right hand side of any point is odd, right? What you have to do, you have to consider the number of open loop poles plus zeros at right hand side of any point on real axis is odd. This is to be considered. What does it mean? This actually means and how to get it clearly. That means you have to consider any point. Say for example, this is your rightmost pole positions here in this example. So if this is your rightmost pole positions, so after this you have to consider the right hand side of this pole. So is there any pole or zero? No. So there is no pole and zero at the right hand side of the rightmost positions, pole or zeros, right? So you have to go back to these positions. We are considering these positions as your reference positions, right? So here after this point you see what is the total number of, if the point is here, what is the total number of pole plus zeros? 1, right? Total number of open loop poles plus zeros at the right hand side of any point. You are considering this point is your any point, and right side of this is having total number of pole, that is pole plus 0 in this case equal to 1, which is odd, right? If this number is odd, then there is a branch between, there is a branch from the right hand side of that that is from the pole of 0, which stays or resides on the right hand side of that particular point to the next pole or 0, right? So we will have to draw a line like this, say by a bold line. Normally when you draw it by pencil, you just make it a bold line to identify there is a branch between this pole and this pole. Here we are having pole here, this, there may be 0, there may be pole, whatever may be the case. The thing is that we have considered this point as your point of reference. I am repeating this tip, and at the right hand side of this point there is a single pole. That means total number of pole plus 0 of that particular point is odd, 1. If this is odd, then this will be your branch. That means from the right hand side of that point there is a pole to the just immediate left of that particular positions. So you have to consider a branch in between this, right? Next, this point is considered. Next, go back to the left hand side of this point here, right? So if you just move these positions, now we are taking these positions, and at the right hand side of these positions you see how many number of poles and zeros are there. One pole, one pole. That means the total number of pole plus 0 is, you can consider pole plus 0 is odd. So uh, pole plus 0 2, this is even. So if this is even, so there is no branch between the right hand side of that positions to the left hand side of that positions. That means the pole or 0 exists at the right hand side of these positions, that means this pole, and pole or 0 exists between at the left hand side of these positions. So there is no branch between this pole and this pole, right? So this will be as simple as that. That means there is no branch on the real axis between this pole and this pole. Only there is a branch between this pole and this pole, right? Next, all the poles have not been covered so much so far. So what you have to do, you have to shift these positions from there to there, right? At the left hand side of this pole starts from the rightmost pole or 0 and goes to the left hand side poles or zeros and so on, like this. So you now arrived at these positions. Here you see what is the total number of poles and zeros at the right hand side of it. So this is 1, 2 and 3. So pole plus 0 is equal to 3, which is again odd, right? Which is again odd. That means there is a branch between the right hand side of this particular point, pole or 0. Here this is the pole, and left hand side of this. So left hand side of this means this goes to infinity. So there is a path. There is a path from this pole to, I may say it better by red color. This is your branch. Okay. So by the red color I am showing, this is the branch exists, root locus branch. This is basically the root locus branch exists on the real axis. So first of all, you have to find out or identify the branch on the real axis. Branch means through which the poles can move. Branch means, I repeat, the branch means through which the poles can move or zeros can move, right? Or that means see the branch. In this case, what is the branch? There is a branch between this pole at s is equal to 0 to this pole at s is equal to -1, and there is a branch between s is equal to -3 and s is equal to infinity. That means through which these two poles can move. Either this pole can move or this pole can move, because there is a branch. Once there is a path described, then only the poles can move. Similarly, this pole can move in this direction only, and you see there is no path or branch exists between this pole at s is equal to -1 and s is equal to -3. That means what? That means there is not any branch between these two. That means there is no movement of this pole and or of this pole through. So movement of this pole or this pole through this path is not possible, because there is no defined path, right? So first of all, what you have done that the poles, and then you have identified the part on the real axis which is actually within the root locus branch, right? So once this step is finalized, next what is to do? The next step I have written here: the root locus branch starts from open loop poles and terminates at either open loop zeros or infinity. That is important. So we will just remove this part. This part also is not required now. So next step, what is the next step? You see, the root locus branch starts from open loop poles. Open loop poles means this, and when it starts from open loop poles, the at next open loop poles, the value of k is equal to 0, because during discussion of the basic construction of the root locus and the fundamental theory of the root locus, we know the root locus branch or the root locus, that means the path is like this pole may move, this pole may move when the k varies from 0 to infinity. That means actually the system gain is varied from 0 to infinity, and accordingly to that, what happens, that is the roots are moving in different directions. They may be directions like this, right? So that was the fundamental issue, and already we have discussed this. Now the thing is that when you have selected or you have identified the open loop poles where the gain is k, so you have to mark these positions at s is equal to 0 as k is equal to 0. That means this is the open loop pole positions where gain is 0. Similarly, here also you will find the open loop gain k is equal to 0, and here also the open loop gain k is equal to 0. You can find it, right? So now the poles, open loop zeros, open loop gains at poles have identified. Now the next thing is that when the root locus branch, say any root locus branch originates from this pole, so the value of k is equal to 0. That means when k is vary from 0 to infinity, means when the value of k will be infinity, that is definitely when this branch may terminate at infinity, right? So maybe this is s is equal to plus 1, say this is s is equal to infinity. So when this branch moves to infinity, the value of gain will be automatically infinity, right? This is the case. Second thing is that when there will be any open loop 0, so what is the actually consequence? What will happen if there is open loop 0? Say for example, this is your open loop pole, k is equal to 0. So when you place any open loop 0 on the real axis or any imaginary axis, what is the value of k there? At open loop 0, the value of k is equal to infinity. That means terminate at either open loop 0 or infinity. In both the cases, that means at open loop 0 or infinity, the value of k is equal to infinity, right? So when this open loop, that means any branch originates from k is equal to 0, so definitely this branch may terminate either at open loop 0 or infinity, anyway, depending upon the availability of the 0. If there is 0, so open loop pole may terminate at open loop 0. If there is no 0, there is certain possibility such that the open loop pole will terminate at infinity, and in every case the value of k will be infinity, right? So this is your k is equal to 0, k is equal to 0, k is equal to 0. So the thing is that next thing is that we will consider the next point. What is the next point? Next point is that, see, till now we have discussed that open loop pole, that means the root locus branch originates from, I will write here, the open loop poles originates from, the root locus branch originates from open loop poles, okay? Now, and they terminates at open loop 0 or infinity. So how many branch will terminate to open loop 0 and how many branch will terminate to open loop infinity? That is the question. The question is that if there is n open loop pole number and m is open loop 0, right? So if, say for example, there are 3 pole and 0 0, then what happens? There is no 0, so there is no position to terminate the all poles to zeros. Definitely all three poles will terminate at infinity. That means actually n minus m, n is the number of open loop poles, m is the number of open loop 0. So in any case, n minus m number of branch terminates at infinity. So termination of the infinity is very simple. In this case, you see, in this case, n is equal to 3 and m is equal to 0. Already we know it, right? So there are three number of open loop poles. We see it, and there is no 0, open loop 0. That means all these three poles will have to terminate at infinity because n minus m. If say for example there was one open loop 0, that means one pole will terminate to 1 0, one pole may terminate to 1 0, right? So rest of the two poles will have to be moved to infinity to get terminated. So similarly here also n minus m, that means 3 minus 1. So number of branch will terminates at infinity, that is your n minus m. So we will come back to our problem. Next thing is that, say for example here you see this is the structure, and here you see this is pole, this is pole, this is pole, and you see there will be three branches then. So number of branches, name, next I will consider the number of branches. Next step, number of branches. So number of branches equal to number of open loop poles, right? So here there are three number of open loop poles are there, so definitely there will be three branches according to this problem. So three branches will be available. So three branches will originate from where? All the branches will originate from pole. So three branches will originate from these three open loop poles. One branch will originate from here, one branch will originate from here, one branch will originate from here. There is no problem, right? So originate is clear and termination is also clear in this case because there will be three branches. These three branches will originate from open loop poles, and as there are no open loop zeros, that means all the poles, all the branches will terminate at infinity. So there is no question about it. So if all the branches will terminate at infinity, so in which direction they will go to infinity, right? So that is the question, in which route they will move, right? Say for example I am taking the structure like this, or you may say this is the structure like this. This is your open loop pole, this is your open loop pole, and maybe there is an open loop pole. So one branch will originate from here, one branch will originate from one branch will originate from here, and all these three branches will move to infinity. So infinity means this may go this direction, this may go this direction, this may goes in this directions, or this may goes this direction, this may goes this direction, this may goes this direction, right? There are infinite number of paths can be available. So in that case we will not trace the actual route through which the poles or routes are moving. That is the purpose of root locus. Locus means this is specified path. So actually next rule comes here. So next point is that the open loop poles will terminate either at 0 or infinity along some asymptotes. Along some asymptotes. Asymptotes basically straight line. But there may be different kinds of straight lines. So the next point comes, there is a specified angle through which the asymptotes are drawn, right? So maybe this is one asymptote, this is one asymptote, this is one asymptote, this is one, all these are the asymptotes. But how can you understand whether this will be the actual asymptote, this will be the actual asymptote, this will be the actual asymptote. So in this case, what you have to do, you have to find out the asymptotic angle through which the asymptotes are drawn. So asymptotic angle. Next point is that you have to draw some asymptotic angle, right? You have to find out the asymptotic angle, and this asymptotic angle is given by phi a, that is 2 cube plus 1 into 180 degree by n minus m. That is the formula by which you have to find out the asymptotic angle. That means once these open loop poles, that means the branches will originate at open loop poles and goes to either 0 or infinity. They will go along the asymptotes, and these asymptotes are drawn with the corresponding angle like phi a equal to, you see, 2 cube plus 1 into 180 degree by n minus m. And where n and m, you know the terms, and this is simple 180 degree, and the value of q varies like 0, 1, 2 up to n minus 1, right? So this is the asymptotic angle. Now, so after having this step, next step, according to our theoretical description, we will find the asymptotic angle for this particular problem. So what is the asymptotic angle? We will write the generalized formula, that is phi is equal to 2q plus 1 into 180 degree by n minus m, where q varies from 0, 1 up to n minus m minus 1, right? And see, here the n is 3, m is 0. So we may write the formula like phi 2q plus 1 into 180 degree by 3 minus 0. So that means 60 degree multiplied by 2q plus 1. And you see, n minus 1. So what is the value of n minus m minus 1 here? That is q 0, this is 2, 3 minus 0 minus 1, 3. So q will be 0, 1 and 2. That means the last value of q will be 2. So 0, 1, dot 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 after 2, that is 0, 1, 2. There will be 3 values of q for which you will get the phi. That means what are the number of phi you will get? For q is equal to 0, you will be having one value, that is we may call phi 1. For q is equal to 1, you will be having phi 2. For q is equal to 2, you will be having phi 3. So you will be having phi 1, that is your 60 degree, phi 2 equal to just value of q is equal to 1, that means 180 degree, and phi 3, this is your 300 degree, right? So these are the asymptotic angles. Now once the angles are obtained, so how to draw the angles, where to draw the angles? There may be infinite number of space, right? What I was talking about is that, say this is one asymptote, here you can draw this is for example 60 degree. So similarly here you can draw 60 degree, here you can draw 60 degree, right? So and most important is that if this is 60 degree drawn here, maybe 180 degree point is drawn here and 300 degree drawn here like this. So definitely there is certain rule that is known as centroid. Once you have to draw the asymptotes, so the thing is that next come, that is known as centroid. What is this centroid? Centroid means the point on the real axis where all the asymptotes will meet. So that point is very important, but that is having no relationship, all these pole positions, zeros positions, all these things. So we have to find out one centroid where these three angles will basically meet, or there is a point from where we have to get all these angles, right? So centroid is denoted by sigma, that is equal to the real summation of real part of poles minus summation real part of zeros divided by n minus m. Summation real part of poles, that means, for example, there are three poles which are having the complex quantity. Complex quantity means, say for example, the poles at S is equal to minus 3 plus J4. But for our considerations, we will have to consider only the real part. That means only minus 3 will take. We will reject that sections. And if the poles are having real parts, so there is no problem. Only the real parts will be taken into considerations. So in this case, what are the three positions? You know, one is S is equal to 0. That means for sigma, you have to find out the real part of the pole summation. That means first pole is at 0 plus minus 1 minus 3. So these are the three real parts of the poles. One is 0, one is minus 1 and one is minus 3. So there is no complex part, so no need to worry about it. Minus the summation real part of the zeros. Similarly, if there are any zeros exist in the system, so there is no problem, but here there is no 0, so this is simply 0, and n minus m is your 3, you know, so that is minus 4 by 3 minus 1.33. so minus 1.33 is your centroid. So thing is that next part, what you have to do, we have to point out the point minus 1.33 on this real axis, and from where, by using protector, we will have to make the angle, right? So what are the different angles? We know 60 degree, 180 degree and 300 degree. And what is the value of this centroid? Minus 1.33. So we will identify the point minus 1.33 on the real axis, and that is, say, minus, this is your minus 1, so minus 1.33 somewhere like here. So this is your sigma is equal to minus 1.33, right? So this is your sigma minus 1.33. Here we just put one protector. So protector structure is like this, you know, the shape of the protector is like this. This is your minus 1.33 point, right? Here you place your protector, and by this protector you just make the angle 60 degree with respect to horizontal line. Angle is made with respect to horizontal line and anti-clockwise directions. This is very important. All the positive angles are measured in anti-clockwise direction. That means if the protector is placed here, see, I have placed, say for example, one protector here, and 60 degree we have to make. So what we have to do, we have to measure from there, because with respect to this horizontal line we have to get the angle. So you see the angle will be 60 degree. So 60 degree angle, you just point out, this is your 60 degree angle, and from this point, this is your minus 1.33, you just draw a line. So this angle is your 60 degree, fine. So what is the angle you get? This is your 60 degree, fine. Next angle is 180 degree. 180 degree is, again, that is your protector. So 180 degree means starting from these positions you have to go to this part, right? So from here you have to draw another, this angle is 180 degree, right? So this angle is 180 degree. So this is one asymptote along this line. This is one asymptote, this is 60 degree, and another is 300 degree. 300 degree means, actually this is 160 degree, 180 degree, and next if you just rotate the protector like this in the downward directions, so you will get another. So now protector is placed like this, If the protected is placed like this, so this is 160 degree, because you have to start from these positions in anti-clockwise directions. All these angles will have to be measured. So this is 160, and again you have to move by your 120 degree. So this is 90, and here this is 120 degree. So this gives you the angle of 300 degree. So this is your line. So you get total angle is 300 degree. Fine. So this is the way how you have drawn the corresponding centroids and the asymptotes. What are the number of asymptotes you required number of asymptotes you know, and from that the defined asymptotic angles you draw. So till now what we have done, we have just formulated up to this. Now you know the root locus branch will originate from this position, and these positions. We know where are the branches on the real axis exist, and we know in which way this branch will move to infinity, because there is no zero, or if there is any zero, these may move along these asymptotes, right? So I will redraw this structure up to this, but what we have done, and in the next part of this lecture I will discuss or complete this problem, that solution of this problem. Okay, thank you.